Hello everyone and welcome to ovesen.net Arctic Retro Computers. In this video I'm gonna take a look at this Commodore VIC20 and I also got some accessories that I'm gonna build for it. I don't know the state of this machine. I have turned it on and it did power on, so I know it's working somewhat, but we're gonna do the regular stuff with the inspection and the cleaning and some recapping, and then I'm gonna build a couple of things. I have the hyper expander and the diagnostics test harness in this box. The VIC20 looks to be in very good shape on the outside. It has some marks, of course, on dirt, and it is, of course, a little bit yellowed plastic, but otherwise it looks quite alright. So the first thing I'm gonna do is to hook it up to my television, and let's see if it is powering on still. Yep, still works, but the picture is kind of bad, so maybe it has some issues. So the VIC20 doesn't have a RF modulator, so I'm using this cable here, which takes composite from the video output to a SCART connector on my TV, and I seems to remember that another VIC20 that I have had a much clearer picture than this. And the keyboard seems to have issues. A and Q does not work. 7, 8 does not work. So there are issues to be fixed, and I'm gonna test this Omega Race game and see if it works with that. Yeah, it seems to work. Needs a joystick or a paddle. This is a classic game for the VIC20. Alright, let me address the keyboard issue at least, and I'm gonna open the machine now. It's only 3 screws in the front, same as with the Commodore 64 bread bin cases. I actually never had a VIC20 back in the day, and I actually started with a VTech Laser 200 computer back in the day, and then I jumped directly to the Commodore 64. So never had a VIC20 experience. Oops. Try not to rip out the LED wire. So the inside and the motherboard looks really nice, not dirty and no corrosion or anything as I can see. But I'm still gonna remove the motherboard from the case because I want to clean up everything, and cleaning the case requires the motherboard to be taken out, of course. Then the keyboard needs to be gone. 8 screws. The keyboard is in fact not very dirty at all. A little bit of dust, but otherwise it's really nice. So I don't think that's the reason it doesn't work. So maybe this machine hasn't been used much, since it still has protected plastic on the spacebar, which I'm gonna remove now. To clean the keyboard, I'm gonna take off all the keycaps, even though it's maybe not that necessary, but I still wanna give them a good rinse anyway. So the most probable cause this keyboard isn't working is that the keyboard membrane underneath the PCB is somehow damaged, or yeah. So I'm gonna take off the PCB and try to clean it. Lots of small screws, but I have a little electric screwdriver. This is quite handy for small screws like this. Let's peek inside. And yeah, the caps lock key is holding this back. Now I just loosen the tape and then it can be flipped over without desoldering. Good. And here we see these rubbery things that are the spring for the keys. So this is a bit special keyboard, and all of this has these plungers in the middle that I guess it's carbon, and all this pressed down to its individual contact, and this is just a copper contact. So yeah, all this needs to be cleaned. Alright, I'm gonna take all these off and try to clean them. I'm not really sure how to best clean these, but yeah, we'll see. Now the electrical contacts do look very nice and shiny, but yeah, there might be some oxidation, you never know. So I'm gonna clean this now with some isopropanol. So I think I'm just gonna clean this with some hot soapy water. Not too hot obviously, but and a little less soap than usual. Inspecting the board a little bit, and it is as I mentioned, quite clean. So but I'm just gonna go over it with some IPA and do a little cleaning. So the keys and those little springy contacts, I don't know what they are called, they are now cleaned, and my next step was to use a little bit of electro cleaner on these pads. So I'm using a cotton swab just with a little electro cleaner and try to clean a little bit more. So this is the last one. These aren't really dirty or anything, it's just that by using some electronic cleaner you remove any oxidation that might be on the little contact. And it might be that oxidation that makes the resistance in the little contact pad too high for the computer to register. So if we want to test, we can actually, for example, test the resistance between this point here and this point here, which is in fact those two pins. And of course now it's an open circuit, so there is indefinite resistance. And then if we place this contact here, now we should be able to detect a fairly low resistance if we push down this one, the gray, and then this one. So now if I push down, yeah, it's actually, it's detecting, it's down to 400 ohms now. Okay, so now all these springy pads go down into each of the keys like this. That was all the pads, and now I'm gonna put back the PCB backplate. And all the little screws. The keyboard is assembled except for the keycaps, and I'm gonna test if it's any better now. So let's see. Yeah, no, 7 and 8 still not working. Nope. This was actually not an improvement, so that probably means that there's something else is wrong. So I connected another keyboard, and it of course works as expected. So that means that the fault is not in the machine, but in the keyboard itself. I've opened up the keyboard again, and yeah, just as before, the keys 6, 7, 8 and 9 and 0 does not work, as well as the space key, and that was the same from the start. So, and these are not to blame because they have been swapped around, so it's unlikely that the same keys should fail then if it was something with the keypads. So then I'm gonna check the traces from the ones that I know does not work. I already checked the continuity on every wire, and it all checked out fine. So I've checked all the traces on the PCB, and everything looks fine. One thing I'm gonna try is to just use a fiberglass pen on all the keypads just to freshen up the contacts so that they are shiny. So that made them a lot more responsive, I think. Yeah, this is much better, and even the space key now works. It didn't work before. So now I'm hopeful. Now let's see if it's any better. Yeah, space key is working. 6, 7, 8, 9, 0 is working. Oops, there's one there, it's not working. K, no, it's working. Just a little hard. L. Shift is working. So this is working pretty good now, except for the K that needs a little bit of force. Alright, I'm in my kitchen now, and it's time for a little retrobrighting, and I'm using, as always, my 12% hydrogen peroxide cream. And this bottle is now empty, but I got a new one. So I just distributed evenly as much as possible around the case. Then I wrap it in plastic film. Same with the back case. And since there's no sun today, I'm just gonna use my oven at 50 degrees Celsius. I have found that this works just as good. So I went ahead and opened the keyboard once more, and used the fiberglass pen a little bit more on this key here, the K, and now it is very smooth. So yeah, this keyboard is now 100% nice. Alright, so the video output from this machine doesn't seem to be the best, as you can see, and I'm not really sure how to deal with that, but I was thinking about trying to adjust. There are some variable resistor or capacitor, I think, on the video circuit. And this is the video circuit, and this is the VIC chip, and here is a little... yeah, I think it is a variable resistor, and this is a variable capacitor. I might be wrong, I haven't really looked it up. So I'm just gonna try and adjust a little bit. Okay. Oh, look at that. Huh. That's a big improvement. Fantastic. From that, yeah, that was the beginning, and turn it all the way left. Now it's almost crystal clear. Nice. So I have zoomed in a bit, and now you can see the difference. Of course, filming onto the screen does not give the correct representation, but yeah, it was almost like this, and now it turned into this. Alrighty, next thing I'm gonna do is to recap the board while I have it out, and yeah, there's only 6 caps and I got them all. Electrolyte caps, that is. And after the recapping, I'm gonna start building the hyper expander and start playing with this machine. So stay tuned. So the list of electrolyte caps. And I'd also like to make a little drawing where all the caps are relative to each other and where the negative side is and the value. Time to heat up the trusty old desoldering station and do the desoldering. Then I use a little solder wick just to clean up the solder pads after the soldering, so there's no leftover old solder tin. Then in with the new caps, and these are really good brand caps. I think it's Nichicon. Should last for many years to come. A little bit of extra flux. Sometimes I don't use it, especially on new PCBs, but these old ones I tend to use a little bit of extra flux. Alright, let's do some soldering. Finally, a little bit of cleaning, any leftover flux. So while I have my soldering iron hot, I'm gonna touch up on the solder joints for the contacts, because these have been under mechanical stress, and the solder joints might be bad or starting to become bad. So I'll just heat them up a little bit and add a little bit of extra flux. That should strengthen them. Last thing I'm gonna do with this bar now is to clean up the edge connectors, and yeah, I use this fiberglass pen makes them a lot shinier, perhaps better contact. The retrobrighting is complete, and look at that. I think this is a very good result. All white and shiny, maybe a little bit of a greenish hint, but that's almost nothing. One more thing, I'm gonna add a couple of heat sinks to some of the chips, like the VIC chip and the CPU. Let's see if the machine still works after the recapping. Yes, it does. Nice. Alright, look at that. Another beautiful Commodore machine saved from the recycling and e-waste hell. Nice. It's time to move on to the next part of this video. Now it's time for some building, and this is in fact the PCB for the VIC20 Hyper Expander. The Hyper Expander is an extension cartridge, and it is actually designed by Sven Petersen, and I got it from him along with all the necessary components that I need to build it, including the testing harness for the diagnostics part of this cartridge. Sven Petersen is an electronics engineer from Germany, and he has a lot of cool projects out on GitHub, and you should visit his page, Sven Petersen 1965. And I have previously built a couple of his other products, and they are well made and always well documented. This Hyper Expander for the VIC20 is actually a superset from the original Commodore VIC20 1211A Super Expander. That one had 3 kilobytes of extra RAM for the VIC20. But this one can have up to 32 kilobytes of extra RAM, and also it has a place for up to 2 different ROMs. That is, you can have 2 different 16K EEPROMs, and it is written here in the silk screen what types of EEPROMs it supports. So this should be a fairly easy build. It's all through-hole components, and yeah. Standard components, a couple of sockets, resistors, and yeah, some jumpers, a few diodes, and a few small capacitors. And it's all very well documented in this long multi-page document. Contains all the information you need about the project, and yeah. This is great stuff. And this is only revision 0, so there might be additional features or revisions on this soon. And here are 1 EEPROM and 1 32 kilobyte RAM and 1 logic chip. And the EEPROM that Sven supplied with this is this one. It's RAM test and diagnostics testing, and that means that the other socket is available for whatever you want to put onto this. And what chip is used, or what bank on the chips are used, you can control with some jumpers. I'll get into that later. Alright, so I'm gonna solder up this one now, and I'm not gonna show all the soldering details this time. Alrighty, that was the soldering, and now just a little bit of cleaning, and this board is ready to be tested. So this board actually looks very nice, and the silk screen has all the necessary information, no problems at all. Now I'm gonna insert the RAM chip, and it is HM62256 BLP. Finally, the EEPROM. Alright, now it's just a matter of configuring this board with the provided jumpers, and by configuring, I mean you set the jumpers to reflect the amount of RAM you want and what kinds of banks in the ROM you're going to use. I have looked through the documentation, and as I understand it, you control which memory area you map the different 8K blocks of the EEPROM with this chip select lines here, and yeah, the jumpers for address lines here, and the memory configuration is configured by the jumpers here. So now the chip 1 chip select is configured to use block 5, and the other one is not relevant, it's not in use, and block 5 is from address A000. And this configuration of the RAM should set up the use of the full 32K, so it should report some 28,000 something bytes free then. I'm gonna insert a cartridge, test a little bit. So come on, oh, it's hard. There it is. Alright, we have a picture on the screen, and indeed it says 28,023 bytes free. So the hyper expander actually is containing the ROM for the super expander, and the original super expander had a lot of additional basic commands. Some of them were mapped to the F keys, and let's see now if I press F1. Yeah, graphic. F2 draw, F5 circle. Yeah, so that means that the super expander ROM is in memory now. So documentation actually has a lot of tests that you can perform to test the cartridge, and yeah, let's test something else. It says here that you can start a monitor. The VIC machine code monitor by typing sys 11 times 4096. Yeah, works too. VIC20 Micromon V1.2 from Bill G in 83. Next test is to actually run the memory test, and that one is another ROM into another bank in the EEPROM, and to execute that I need to switch bank by removing this jumper here. Alright, there you go, memory test. Found, yes, run, okay. So this just repeats itself indefinitely and tests all the RAM. And next I want to do is to test with another ROM and populate the second socket here. And as you can see on the silk screen and also in the documentation, this board supports 512, 256, 128 and 64 kilobit EEPROMs, so that's great. So I got an Atmel 27256 EEPROM here, and this should fit, and I'm gonna burn something onto it now, some game or something, not really sure. If you go to simmers.net, you'll find a lot of useful information about Commodore machines, and here's a VIC20 area, and it has some game cartridges into these subdirectories, and this 16K directory contains 16K game cartridges like Arachnoid, and I thought I'll test the Donkey Kong, and this is a 16K game. It's divided into two 8K ROMs, so I just downloaded both these. Yeah, I want to keep them even if it's dangerous. But you see here the file type is not exactly 8K, it's 8194, while 8K is actually 8192, so it has 2 extra bytes. And to fix that and strip out the extra bytes, I actually use a program called HXD, which is a binary editor and freeware. So then I just drag the file into the program, and to remove the first 2 bytes that should not be there when you burn it to the EEPROM, you just select the 2 bytes and then cut. And then it says you will change the file size. Yeah, that's exactly what I want. And then just save, and then I take the other one. So that's it. Now you see the old file, which is kept as a backup, is indicated as 9 kilobytes, while the new files are exactly 8 kilobytes. And of course you need a EEPROM burner, and I got this one quite cheap a while back ago from eBay, and cost me around 60 euros with shipping included, I think. Then the 2 ROMs need to be burned on the two separate EEPROMs, and I have selected the correct EEPROM, which is Atmel 27256 in a DIP28 package, and yeah, and then I'm just gonna load the file into the burner software. First file. Just keep the defaults. Then you just hit program and program. Programming successful. Nice. And then I'll do the same with the other file. So now I got the 2 EEPROMs, and I mark the first with 1 white dot and the second with 2 white dots. And I took out the Super Expander RAM testing EEPROM. So the second one should go into IC1. So it's a bit of a reverse, but the first should go into IC2. And those two EEPROMs, the memory area that is burnt onto those should be mapped onto different memory areas in the VIC20. And the first one with the A000 address, you should select the block 5, which is this setting, and for the IC2 you should select block 1, which is this one. Then it will be located at address 2000 hex. I also took out all the jumpers for the memory configuration because now we don't need extra memory. So let's see if this works. Donkey Kong on the VIC20 I have never tested. Yes, have you seen that? Actually works, but the picture is shifted to the left, so seems like an NTSC version. Oh, you can use the cursor key to move the image. Nice. Let's play. So I have hooked up a joystick. Let's see if this works. All right, do not go back when you start. Oops. It's a bit difficult, seems. Oops. Alright, so that actually worked just fine. You can use 16K cartridges with this hyper expander cart solution. Great. So I'm inserting the super expander ROM back into IC1, and what I'm gonna do now is to build the diagnostics test harness.